What's up everyone, today I bring you a tutorial about procedural walkways inside Houdini and how to send them to the Unreal Engine as a point cloud. The origin of this tutorial is a digital asset that I made called walkthrough pattern. It allows for copying of geometry using a pattern. So how it works is we create a bunch of modules and assign a unique ID to them, and we use this ID in the pattern that we can specify in the digital asset. And basically, whatever the pattern describes IDs, then we basically copy the modules in that order from the pattern. So that's where the name walkthrough pattern comes from. So I like to think about this digital asset as an opposite of being a polycurve, as opposite of the polycurves. So if you think about, if you have a digital asset that copies geometry along the polycurves, we usually want to align our polycurves to match whatever the terrain we are instantiating this geometry. But in this case, since we are not following geometry, we are not following a polycurve, our pattern is kind of like our geometry is kind of rigid, and our terrain has to be adjusted to match the whatever the pattern we want to create. So that's one way of thinking about this tool. In this tutorial, I will go through the process of creating base geometry from scratch, UVing geometry, creating high resolution mesh, and making collision for the geometry so that our character inside Unreal can actually traverse the walkway. And also we are going to use the Vertex colors to break up wood texture colors. And what's cool about this, that it doesn't really have, there really isn't any limit on what kind of modules you want to instantiate. It's not really limited to any specific geometry types. And so I'm really a big fan of kind of like a generic tool that can be used as in many different use cases. So it doesn't really have to be necessarily a walkway that you create a pattern from. I will be using a couple of digital assets that I have used before from my procedural building tutorial. So it's not necessarily for me in this tutorial go through all the functionality of these digital assets. So this is not really the point of the video. But if you want to learn more about these digital assets, you can go and watch the procedural building tutorial. And if you get the work file of this tutorial, all the custom digital assets are also included, and they are also documented, so you can learn more about them that way. So if you want to support my tutorial, you can get the complete zip file and all the custom digital assets that I am showing this tutorial from the link in the pinned comment. It really helps me bringing you new tutorials in the future. With that out of the way, let's get started. Let's start by going through this heap file and see how these walkways are set up. So first of all, I have two geometry subnetworks, the actual instantiated walkway, and then I also have a walkway source, which is basically all the geometry that has been, basically all the source geometry that is that composes the created walkway. So let's start by walkway source, how each part of this walkway is actually created. So let's start by basic platforms. So the platforms are created by this for each loop. And if you take a look at let's go to the single pass, you can see I have 3 platforms, but with this setup we can basically create however many you want, which is basically cut at the different angles. So I have basically a straight platform with no cut. I have at 45 degrees and also at 30 degrees. So any platforms with the cuts would be considered as a corner pieces. So you can imagine that if you go ahead and copy this platform and place it along here, we would have our 90-degree corner, and same with it for the 30 degrees. If we connect it, we would have our corner like that. So let's go through let's turn on the single pass, and these platforms are controlled by this null node platform controls. So let's take a look at the basic controls. By universal controls, we can change the thickness of the boards, we can change the width of each board by the base boards, the length of the platform, and the total number of them, and then the spacing between each board. So these are universal controls for all the platforms. And then for the for the individual platform, we obviously have to give it a unique name, because this name is going to be used as a save name on disk for each one of these. And I just use a wood platform, and with the angle of the cut with each one of them. And then we also have to give it angle at which to cut our platform on off. And the angle is basically calculated from the vector, that from the direction of the positive z-axis. So you can imagine that if the positive z-axis points here, and if we rotate 30 degrees clockwise, it would basically point in this direction, and so that would be a 30-degree cut. So this is how the angle is actually calculated with these angle parameters. So let's go through this and how it's set up quickly. So first of all, we have our box, we have our sizes, and the sizes are set up from here, from thickness, width, and length, all of these. Then we copy, we have our copy, we check our width from our control nodes, the width, and then the spacing of it, because we want our spacing between the boards. And then we go ahead and match it to make sure that all the geometry is actually moved on the positive z-axis. Then we also give it a group. I just call it a deck, like that. And then for each loop, it's pretty simple. The most involved part is actually the cutting it at the appropriate angle, and this is where the cut plane comes in handy. So inside here we have our deck, we have our multi-parameter counter. Again, we take a look at basically we create a huge grid. Actually, it's not really all that big. Basically, we need our cut grid. So this can be actually, to make sure that it's always cuts, we can make it very big, like 100 by 100, and we match size it at the end of at the length and at the left corner of the end of these the platform, and then we just go ahead and rotate it. So you can imagine that we can match the size. Then we also want to rotate it, and since the basically take a pivot and move pivot to this location. Basically take a pivot and move it to this location inside the transform node, and then we rotate it by the angle amount inside the multi-parameter from the control node, and add a negative on front of it because of the rotations. Basically, in the rotate nodes, the rotation actually happens with the clockwise, happens with the negative angle value. And basically we have this cut plane. We go ahead and extrude it by a big amount. And then we also make sure that we also extrude sides. And then we just dissolve it. And this is our cut plane. Basically a big cut plane, which is going to make sure that we always cut whatever the platform we have here. And then we just go ahead and take a boolean and cut it. Then we take a look at and fuse it, because these are not actually going to be fused. These points are not going to be fused. And once we have fused them, we want to go ahead and expand our deck group. So deck group, after the boolean, these primitives are not actually going to be inside the deck group. So it's to go ahead and put down a poly extrude, poly expand, and we just go ahead and expand it, the deck. Then we put down a connectivity node. So this is going to make sure that for each one of these boards, there's actually a unique attribute for them, which is probably not even necessary in this case anymore, because this might be left over from the previous setup for me. And then we want to go ahead and give it a name, and the name is going to be the fetch name from this multi-parameter, and we set it as a primitive attribute inside here. It's going to be our unique name for each piece of the geometry. And then we also want to go ahead and pass some metadata for the railings for each one of these, because inside here we only create our platforms or decks, and the railings also need some information about at what angle to cut. So we go ahead and set the type to deck, and also angle to the value of the multi-parameter. And this is done for each one of these, like that. And for the platform railing, you can see it's pretty involved. Let's go through this real fast. So let me go ahead and do it for single node. So at the end of it, you can see I have one single railing. Let me go ahead and take like angled railing. You can see we have two pieces that are being cut and centered on the positive z-axis. So let's go through this. So first of all, we get our angled piece. We go ahead and take our polyline. We match it to the length of the bounding box of our input deck. We want to make sure that our geometry is longer than that because we're going to cut it. So this is where basically we go take a transform, we scale it by 2. That's going to make sure that it's a lot bigger than the actual platform. Move it on the middle to make sure that it's going to be cut appropriately at the both sides. And then we just sweep it, and now we have this big railing. Then we want to go ahead and cut it. So first of all we want to move each one of these railings on its basically on the outer parts of the deck. So the right railing is going to be by using the match size nodes, you can just justify max to min and min to max on both sides. And if we merge them together, you can see that relative to our input deck, both of these are basically on the outer sides. Railing is on the outer sides. And the cutting of it is actually pretty simple. We first of all take a shrink wrap node and shrink wrap our geometry. We put down a normal. We poly extrude with the normal. We go ahead and poly extrude only the. You basically only poly extrude the. Let's take a look at it. We extrude only the only up and bottom parts of the geometry. As you can see, you go ahead and extrude it, and I have not actually outputted the front of it, so that's why it looks a little weird. But without outputting, we can just basically extruding it upwards and downwards. We then dissolve the flat edges. We put down another normal node. Then we blast anything that is not pointing anything that points to either positive or negative x-axis. And then what we do is just extrude it again by a lot, and then we just dissolve it and use this input shape as a boolean inside here. And this is going to give it our cutoff shape for our decks. You can see if you take a look at the end result of the cut, we have cut it appropriately for the angle of the deck. After the boolean, we want to go ahead and sort our points. So I put down a sort node, and we want to sort by x-axis. So this will mean that our initial points on both of these railings are going to be on the negative x-axis of the negative x-axis, and the last points are going to be on the positive x-axis. So this is important because you want to put down a connectivity node, and the connectivity node is going to work. It's going to give a unique integer value for both of these connected pieces based on their point number. So by making sure that we put down a sort node, this is going to make sure that our piece on the right side is always going to be piece 0, and on the right side, on the left side, is also going to be always going to be our piece 1. And then we can just go ahead and split it by pieces. And after that, we want to go ahead and set our attributes on it. So I want to go ahead and use an object merge for the basically for the input geometry. Instead of me dragging out a long wire, I just want to go ahead and put down object merge, because I want to go ahead and get the name of this platform and append the word railing right and railing left on it to make sure that the geometry names are consistent. So I just go ahead and take the base name, which is just taking from the first primitive the name of it, which is already set up inside here, and just create my name attribute by adding the railing right and railing left in a wrangle. And then I just want to go ahead and match it to the center, and I'm making sure that the center is actually it is in the center of the y-axis, and all the geometry is actually on the positive z-axis to be consistent with all the geometry. And then I just merge them, end it, let's turn off single pass, and I go ahead and give it a group, a deck railing. So we are done with the platforms. Let's go to the support beams. So the support beams are probably the most straightforward part of the network, which is just basically different different size and length rectangles. If you take a look at the support beams, let's go to the single pass on it. So I have basically set up two types of support beams. One are 20 by 20 centimeters, another one is 10 by 10 centimeters, and with different lengths. And the lengths can basically set up arbitrary. It doesn't really matter what the size of them are. But the idea for me was to make sure that there are one length of the support beam with the length of the deck. So you can imagine that for the deck, you want to go ahead and have something that is some support beams that are exactly the length of the width of the deck, and also the length of the deck. So I have basically all support beams with the ones that are 10 by 10 and 20 by 20 that are sizes by the width and length of the deck. And then I also have a custom one, which is 6 meters long, which is basically just ones that are going to be inside the ground when we start to instantiating, to make sure that basically we need something to hold up our platforms, and this is going to be inside the ground. So we can really make it even longer if you want for this to be even higher off the ground, but 6 meters seems to work just fine for me. So the platform, so the beams are very simple, and these are just references to base platform bounding box sizes. So you see bounding box for D size and the D size. And if you remember, we have already set it up as 3, so these sizes, and also the same one is for the 1 by 1 beams and for the 2 by 2 beams, 0.2 and 0.1 beams, and the big one is 6. So this is going to be the big beam. Should be this one. And one last thing that we need is our stairs. So I have 4 types of stairs. So I have a main stair which goes upwards and downwards, and also have a one for each up and down, which basically kind of like which is going to be start of the pattern stairs, which is basically just maybe without the railing. That's just a small steps that gets you off the ground and on the actual path of the walkway. So these are 2 small steps, like we get on the path on the walkway and off the walkway. So let's go through these. Let's go to the main. So the main stairs are like here, and the controls for them are also inside here. So this is going to be the first stairs, which is, I think, this. So we can control our angle. So let's put something like a 50. So basically just how steep is our stairs. Like that. Then we can how many steps you want. And also we have our support count. So I have to fix it because the support count is not actually consistent with what we have in the viewport. It's actually one less than this one. So you can see that however many supports you want, we can get them in there. Also the unique name and the width of each step. So for me something like 0.3 seemed fine for the stairs. So these are all the controls, and then we also have to say which direction they go, upwards or downwards. And basically the relative references are just the copies from the previous, basically these are duplicate stairs. The only difference is that it's going downwards. So since I want to basically the same stairs that goes upwards and downwards, and this is the only difference. These are all the relative references for both stair types, the small ones and the big ones. And the only difference is that one goes up and other goes down. So you can see that angle, all these are relative references. Let's go through the main logic of it. So first of all, we have our box that controls the sizes from the control node, and then we go ahead and create a large line, and we basically want to control the size of our line. So this is pretty tricky to create. Basically, each one of these points are going to be one step, and we have to make sure that these steps do not overlap each other on the different planes. So this is done by pretty tricky logic. First of all, we have our line that goes on in the positive z-axis, and then we resample it by the width of each step from the control node, which I showed off. And the segment is how many steps we have from the control node. And then so this is our steps, which are basically our flat steps, and this is going to ensure that our steps are actually in the difference between each step is actually the one that we have set up on the control node, but we also need to angle it. So this is where the second line comes in handy. So the initial line is inside here, and we transform it based on the angle of the stairs inside this parameter. You also want to make sure, and now what we want to basically do is go ahead and move each one of these points in the position where it intersects, where the instance point polyline intersects with our angle polyline. And this is done by very simple intersect function inside Houdini. If you take a look at it, it's very straightforward. We have we use intersect function. We want to intersect with the second input of the wrangle node. We use our initial position, and the direction that we want to intersect with is a positive y-axis. So basically, this vector acts as a direction and also the length of it. So I just put a huge amount to make sure that it always intersects on the positive y-axis. And then it writes out information inside the vectors, and then we have hit it if it's basically -1. So if the hit is not -1, that means it has hit something. We go ahead and write that position inside our new position for these points. So you can see we have written it out, and this is going to make sure that still our direction between all of these steps are actually consistent with whatever we have set our length for the width of the step, like that. And then we go ahead and create a switch node, whether we want to point upwards or downwards. We just go ahead and put down a mirror node, and then we go ahead and copy the steps like that. We create a group step group. We sort it, we put down a connectivity and blast the first piece of the step because it is intended that the first one is actually going to be on the ground, and we do not want our first step to be on the ground already. So we just go ahead and delete it. And then we want to go ahead and use a middle support, create supports for the sides and for the middle. So the side supports are pretty simple. We go ahead and take our steps. We create a shrink wrap node, put on normal, blast everything but the sides, poly extrude them, and the poly extrude by default there's no really option for us to control what's the thickness of it. So by default it's just going to be multiply the thickness of the board of the step board by 1.5. It just makes sense that supports are a little bit heavier duty than the actual steps, I guess. So I just multiply by 1.5. Then I put down normal, and then I go ahead and put down a support side group, and that's basically it. So the middle supports are a little bit more involved. So we have our steps. We go ahead and we go ahead and extract all the points, and this is where actually the profile group comes in handy. So actually the profile group, I didn't go into details of it, but it's actually manually selected group because our step is never going to change and the points are going to be consistent. We go ahead and select 2 points on either, we can basically select on the either side of it, basically these 2 points. So these are very important because once we create our copy to node, our group is still going to be there. So take a look at our point group, our profile group, and you can already imagine if you go ahead and extract all of these points from the profile group, we can create a new polyline and extrude it to make a support for these stairs. So this is exactly what happened in this middle support. So you go ahead and extract all points, we blast everything but these points, then we sort them based on whether the steps goes upwards or downwards. Because of based on upwards or downwards, you want to delete different points. So that happens there. So in the counter node, we want to get our line. So basically this is the resample node that actually selects how many supports you want. So I'm actually going to go ahead and fix the bug that I have here. So you can see in the resample node, I have my supports set at 3. So what I want to do is go ahead and to make it consistent, I want to go ahead and add 1 to this resample node. So whatever the value it is inside here, I want to go ahead and add 1 like that. It's going to make sure that my support parameter is actually consistent between between these. Let's say I want 2 supports. Now I have 2 like that. So this is actually support count actually fixed now. So let's get back to it. So we have our counter, multi-parameter counter. We go ahead and create a line. We match it to the size of the steps, resample it, and delete last and first point of the polyline. This is going to be our instance points because our resample is always going to make sure that there's equal distance between all the supports. So then we we sort our points based on whether we have upwards or downwards, and then we delete the first point. We go ahead and move it. You can see that we go ahead and since we want a little bit of a space between, because we are going to create a new polygon, we want to make sure that there's a little bit more space to connect last and first point to it. So we go ahead and take a first point and move it downwards, and then we create a new point that's going to also go from the last point downwards like that. And then we just go ahead and add a node. You can see this is our support, and then we just poly extrude, copy the points, match it to the center of the stairs, and then we just go ahead and create a group. And let's take a look at how it's actually is set up inside the downwards. So I don't really remember exactly. So in the downward logic, let's go to the middle. So in this case, we are actually we are reverse sorting our points. So that means that the middle point is actually going to be at the very bottom, and we still delete that one. So we do not want to delete okay, so that means that we do not want to delete the point that's there. So basically the logic is the same, we only we reverse sort if it goes downwards, and the actual logic is actually the same. It's going to create in this one and that one. So yeah, so the only difference in this logic between upwards and downwards stairs is this sort node, the point that we want to actually delete. And then we merge them, we give it a name, again from the multi-parameter, we give it normal. So this is actually not really all that important inside here because we're still going to edit our geometry, and then we pass some metadata like angle, direction, and the type. And then we want to generate our stair railings. Let's go ahead and disable single pass. In the stair railing, let's go ahead and go through each stair. So we go ahead and delete. So these groups are very important that we have set them up, because we want to get the certain parts of the geometry. So we basically just go ahead and delete this step group. What we're doing here. So we have our line, we have our transform. Again, we get our angles. So what we're actually doing here? We have our, okay, so we have our direction upwards or downwards. We have our angle polyline. Then we sweep it with the input shape, which I'm going to showcase. So basically we sweep our railing shape. Then we create our cut plane again, match size, poly extrude, match size. On both sides are going to be our cut plane. You can see it's like a very big primitives. So this is pretty over the top, to be honest. So we can make it a little bit more reasonable. So this is our cut plane, and we have cut it at the start and end of it. And this is going to ensure that any module next can connect to our ends. And we just use the match size to match it normal. And then we also want to make sure that our that the geometry is basically is transformed something like here. We just basically center it on the try to center it on the positive z-axis, and that's pretty much it. It's not all that complex inside here, to be honest. And then we just set up our railing stairs, and that's it. All our groups are set up inside here. So this is our stairs. We have basically created all the building blocks for the geometry. And now that we have our base building blocks, you want to go ahead and UV unwrap them. So the UVs are done inside here, and I am doing it in two different ways based on the geometry groups that I have set up. So first of all, I want to calculate primitive normals for all of these pieces, and then I'm going to start by blasting the decks, beams, start, and deck railing groups. So this is going to be UV wrapped inside here, and the rest of it inside here. So since our UVs are going to be so our UVs can be repeated, the texture we're going to use inside Unreal Engine and overall. So that means that we don't have to do much of a UV unwrapping at all. We just want to make sure that UVs are aligned either horizontally or vertically, and that's basically it. And they're going to repeat themselves and look pretty good on the actual model. So it's actually pretty easy to UV unwrap them. So first of all, let me go ahead and put it on the single pass for something like maybe this beam. I'm going to put down automatic auto UV. So it's going to put the UVs in the 1 space, and this is not exactly what I want, because I want to make sure that UVs are actually a size of the actual geometry. So what you can do is put down a textile density, and it's going to scale the UVs as big as they are in the physical space. Then I can just go ahead and transform it vertically, and then just UV layout to make sure that all of them are not overlapping, which doesn't really matter, but it's going to give us at least a different texture for each side of these for this beam. And basically we're doing it for all of them, and that means that these UVs would be good for something since they are pointing, they are vertical. That means they are good for texture that are actually vertical in this way. So this texture would not be a good fit for it, but I have a couple of more. But obviously, whatever the texture you have to look at the UVs. So you can see this is a good one, because these boards are actually vertically, and these UVs would be actually good for something like this texture. And that actually doesn't really matter all that much, because we can always go ahead and rotate them. All of them, go ahead and rotate them. So what I have here in the universal controls, I have rotate by 90 degrees. And you can see that if I go ahead and press rotate 90 degrees, you can just go ahead and rotate our UVs. So this is based on the texture that you're going to use for your walkway. So that's for the first part of the geometry, and the other part is a little bit more trickier because we have these angled pieces. So if we would have unwrapped them this way, that would mean that UVs would be basically want to make sure that all of these angled pieces are flattened along the either horizontally or vertically to lined, so that these angled pieces are also are across the grain. So in this case, what I have inside Unreal Engine, you can see the sides of the stairs are actually following the texture grain or texture inside the material. So I want to make sure that I have that set up. So this is where we are using a UV project. So first of all, I create a new group where I can basically just go ahead and select only the sides of all of these geometry pieces. And this is why the normal node is important in this case. So we just go ahead and select them. Then I use a UV project and I project across the x-axis. And then I'm using a UV layout to lay them out like that. So the project is only on the group left, right, and the UV layout is on all of the geometry. And since I do not have a UVs for the rest of the geometry, it's going to only lay out the ones that already have them, and these are these sides. After that, you can just put down an auto UV, put down textile density, UV transform, and we get something like this. And since we have used our groups, we have to go ahead and fuse back the geometry together. At the end of it, we basically get something like this, a long piece of geometry, but it doesn't really matter as long as it is aligned across the either horizontally or vertically. It's going to look fine on the geometry. And that's basically it for the UV unwrapping. It's pretty simple. It probably could be done a little bit more, efficiently, but these UVs are going to work just fine for the geometry. Now that we have our UVs, we want to go ahead and apply a little bit of a bevel on this geometry. So this is going to give us a little bit more of a natural look once we apply our damage to this geometry. So I found that it's going to look this edge is going to be a little bit more rounded with the small amount of bevel. And since you want to use the geometry inside Unreal Engine, we have to set up a couple of Unreal Engine specific attributes. So all of these attributes are going to be set up as the primitive attributes. In previous videos, I have set them up as a point attributes, but Houdini engine is going to automatically find these attributes. And since I am using information from my already set up primitive attributes, it makes sense that I just go ahead and set them all as the primitive attributes in this case. So let's start by Unreal Material. So our material is just a path to the material to apply to it. So in this case, I have this material. So this material, where is it? Just a path. If you go ahead and copy a reference to this material and paste it inside a material value, it's going to be used as it's going to be automatically applied to this geometry. So the bake folder is very important. So when we import this geometry inside Unreal Engine, we have ability to bake it out and basically make it independent of the digital asset that we have used to import the geometry, and it needs some folder to save this geometry. In this case, I am having my game meshes walkway wood 0 folder, and that folder is basically this one, wood 0, basically path that starts with the game. And this path is my bake folder. It's going to automatically bake it out inside the Unreal Engine's content browser. So then I want to go ahead and set the output name. So the output name is used as a naming for these meshes inside Unreal Engine. How the static mesh is going to be named. And you will notice that I am using basically the name attribute value that I have set up in the all the piece generation inside here. It's basically from these multi-parameters. And you will notice that inside here, since Unreal Engine has a naming scheme that is very common, it's basically indicating with the prefix what this geometry is. In this case, these are static meshes. You can see that I have SM underscore and then the name that I have set up inside the multi-parameter values. But in this case, I have actually skipped this step of adding a static mesh for the names, because I'm going to also provide you with the tool that I have showcased also inside my previous procedural building tool, that we can automatically add a prefix to this geometry. Because right now it doesn't really make sense for me to call this geometry static mesh underscore and the name, because this really, the geometry can also be used in not Unreal Engine, so it's really independent of the game engine, this geometry. So it doesn't really make sense for me to name it static mesh and all of that. So that's why the Unreal output name is still the s at name, and it's not having appended any static mesh prefix. And then also one thing that I can do is to skip the enable nanite inside Unreal Engine. I can go ahead and set Unreal nanite enabled, so this is going to automatically check the box of the enable nanite support for this geometry. Since you're using a pretty big polygon count for each one of these geometry pieces, we have to use obviously not nanite. And then we also want to Unreal input mesh name. So this is very important because we want to create our instance points inside Houdini to trace back to geometry that we have already baked out inside Unreal Engine. So this is kind of like so this attribute, we would get this attribute if we would send our geometry, our baked out geometry. So you can imagine that if we have baked out this geometry inside Unreal Engine, and if we, let's say we select this option to send to Houdini, inside Houdini we would have a new attribute called Unreal input mesh name, and this mesh name can be used as a attribute value on a point to trace back to this geometry inside content browser, inside Houdini, inside Unreal Engine. So that means that instead of us manually importing this geometry back to basically importing this geometry back to Houdini and extracting this exact value from the mesh again, we can go ahead and preemptively set this up because we know where we are actually baking it, and we know the static mesh name that we're going to use for this geometry. And you can see that it's basically going to be the bake folder, and then the static mesh name inside content browser with the dot, and then the static mesh name inside the content browser again. And you can see in this case I have used my SM prefixes in both cases, and that means that I have to save. So that means that I have to make sure that I have inside content browser also these static mesh prefixes, which I'm going to showcase how I set them up very soon. So this kind of like a making sure that we don't have to re-import this geometry back to Houdini and get this Unreal and get this attribute value again. So it's actually a very nice thing to set up. Now that we have set up our Unreal attributes, we want to go ahead and apply some high resolution detail on these geometry pieces. So this is where the top network is going to come in handy, because what we want to basically do is take each one of these unique names, so let's say stairs, and apply damage individually on all of these geometry pieces. And to make it quicker, we want to do it simultaneously on multiple geometry pieces, and this is where the top network is going to come in handy, because we can run this operation of applying high resolution damage at once with multiple work items in the PDG network. So, and the PDG network can be pretty tricky to work with, and if you have not selected correct options for you to separate geometry, it can be kind of frustrating when it starts to cook out automatically. And to prevent this, what I have set up is basically I have automatically disabled, so that when I select this node, it's not going to automatically start to cook this network. So let me go ahead and go through this setup. So first of all, I want to go ahead and save this geometry in the temporary directory. So what I have here is the external in the storage. I have basically this geometry import node is going to save this geometry based on the pieces of the. So we go to the data extraction. Then we go ahead and say for each piece attribute value. And since we know that we have a name attribute for each one of these geometry, we basically say separate, give me a work item for each one of the unique name attribute on this geometry. So we have 22 geometry pieces. And so to go ahead and save this geometry into the temporary directory. So what I have here is my output directory, wood walkway, and what I have here is temporary directory. You can see these names are not very specific to each one of the geometries. So by default, it's going to give something like a PDG index and heap name value for these file names. So this is important because since once we are going to start to run our high resolution geometry across multiple geometries, the next top network needs the geometries to source from, and it can't really source it from this heap file because it's this geometry is basically in a heap file. It needs to read this geometry from the disk. So that's why we have our temporary geometry where we store our low resolution geometry so that our next geometry top node can source this geometry from. And this is basically set up automatically with the input and output files. And if you take a look at the work items on each one of these, the output is basically paths to all of these temporary files on this directory. So, and then we have our ROP geometry, and this the geometry import is a way of saving files. And the ROP geometry is how can we also save files, but we can also apply some edits to it. And then the output file is basically the save directory which I have set up in the universal controls where to save it. And basically, and I'm using the piece value attribute, which is by default given by the top network. Basically, the way that we have since we split our geometry by the piece attribute name in the top network, this attribute is going to automatically name the piece value. You can see if you take a look at start clicking through. So I don't think I can do this. It's not going to update. But you see, but the piece value is going to be the attribute value that we have split by our work items. Wood platform 45, stairs 0, down railing. And then we can use this same attribute value to use it as a save name for this geometry. You can see I have basically used it as p at piece value bgo.sc, and then the save directory. And let's go inside this ROP geometry to take a look what we're actually doing here. And to make sure that you actually see the results, you can go ahead and select like a one work item, and then just go inside this network. It's going to automatically start cooking it. So you can see if we select each one of these work items, we have basically imported the geometry from this temporary geometry. So right now the geometry is sourced from this temporary directory. And we can go ahead and inside this active work item go through it. So let's take something like so it's not very. So this is going to be pretty involved process. So let's go through this. So then we go ahead and put down connectivity primitive. So since we want to run this damage through each one of these pieces, we're just going to do that. Let me go ahead and select this for each loop. So we have now generated our geometry. So you can see it looks a little weird because of this option to also export collision, which I'm going to talk about a little bit later. But basically, let's go ahead and disable this one. Let's run through again. And you can see we have our high resolution stairs with some damage across all of this geometry. And how it is set up, let me go ahead and do a single pass on one of these. It's actually very simple setup. First we use a edge damage node. We do some edge damage. Then we use a poly reduce. We reduce the polygons. So I keep 30%. It looks fine. And then we go ahead and UV transfer. Basically transfer UVs from the input geometry that we set up our UVs from. And then we put down a normal node. In this case I just put the vertices 60 degrees. And then just merge it together, and that's basically it for the high resolution geometry. And the collision, we have option to also merge collision if we have set up if I have turned on this right collision and right collision option toggle. After we have our high resolution mesh ready, we have also option to write some vertex colors into this geometry. So what I have here is ability to write some curvature maps to the vertex colors. So this is interesting because we can basically break up our wood texture by brightening up some parts of this geometry So just by testing it, I went ahead and created ambient occlusion mask. So it's not very too much of a too visible. You can see it's kind of like a darker parts on where the ambient occlusion happens. Then we also have a curvature mask. The curvature mask is pretty important because we can do this kind of like a edge damage, color our material a little bit on the edges of the geometry. And also I have some random noise attribute setup. And then basically all of these are on the points. I go ahead and promote it to the vertex because these are vertex colors that I'm going to export into the Unreal Engine. I go ahead and set up into the single v at cd vertex attribute and just referencing these mask, convexity and noise values inside this attribute, and we have set up our vertex colors for this geometry. And this is also option to turn on, turn off inside this universal controls option. And then basically we switch if we want our vertex colors. And then, since the attributes are actually not going to be saved off once we have done everything, so once we have applied all of these, the attributes are actually going to be destroyed. So what we basically do is go ahead and put down attribute transfer, and we just transfer all the primitive attributes back to our new high resolution geometry. And that's basically it. So the collisions, I didn't talk about collisions, but collisions is, I can quickly talk through the collisions. A collision is actually very simple. For each one of these geometry pieces that we run through, we want to go ahead and set collision geo and then the underscore of the class of the index of the class that we want our collision to be kind of like an index to the collision for this single geometry piece. So the Houdini so there's a Houdini documentation that talks all about this process, and it's very simple. We just have to use a collision geo and underscore index to have basically a multiple collision geometries for the single asset. Like that, because you want to make sure that we actually have a collision for each one of these steps and not like a one, so we don't want like a simple collision, like have a simple wrap around this geometry. You want to actually each step to be its own collision. So this is why the collision geo is important to set up. And then we have also toggle to whether we want to enable it or disable it. Basically write it out or not. And that's basically it for the high resolution geometry. And to show the power of this setup is that we can do it, we can generate these high resolution meshes for multiple geometries at once. I'm going to go ahead and basically delete this temporarily geometry and all the geometry that I have already baked out. So basically I have no geometry right now. I'm going to go ahead and dirty all. Go put down a cook node. So this is going to start cook out our rope geometry. You can see the geometry imported basically finished off instantaneously, but since we want our high resolution mesh, this is going to take some while. But you can see we are already done by 3. We have already done it with the 4 geometry pieces, and you can see they are all saved out into the directory that we have specified. And if you can imagine that we have done this inside our own heap file, we could do it only for the single file at once. But in this time, since we can leverage the multiple threads from our CPU, we can go ahead and basically run through this for simultaneously for multiple geometry pieces. And then we are basically done very quickly with generation of the high resolution geometry. So I'm just going to wait it out. You see, we have basically, and that's it. We have completely generated 22 high resolution geometry pieces. And if you want to see the results, I'm going to also give you my my file scrubber HDA. So I really like this node because it basically gives a walkway. It gives ability to see the geometry on file without using like drop-down menus to select each one of these. We can basically scrub through file scrubber HDA that I'm also going to give you if you support my work by downloading this work file. I'm going to give you also to this one. We can basically see all the high resolution geometry from the bakes. And now let's see how the actual walkways are created. So the walkways are actually created from walkways are combination of modules that we create beforehand. So you can see that inside here I have a couple of modules that we can copy across to create a walkway. So I have my straight walkway, I have my 30-degree walkway, left and right. I have my 45-degree cut walkway, left and right, and also have some stairs. And all these modules are created from the building blocks that we created from the source geometry that I walked through earlier. So let's go through the single module and see how it is created. So first of all, I am using my geometry compositor node, which is now updated from my previous procedural building tutorial, and now it is going to also be updated also for anyone who got that tutorial work file, and also you're going to get it from if you support my work also for this one. So this is the updated version, which involves a little bit more of a user-friendly way of combining geometry. So let me go ahead and recreate this module with the new geometry compositor node. So the idea of this compositor node is that we don't have to go ahead and create a multiple nodes to connect all the geometry together. We can basically use a multi-parameter to reference each geometry and combine it into one. You can see all of this geometry inside here is just a packed disk primitive, and there's actually no geometry inside here. It's just an instance, basically just a point that we can reference as an instance point inside Unreal Engine. So let me go through this. So let me copy the main. So I have saved all my geometry inside wood walkway. So let me go ahead and paste inside here. Let me copy it inside here. So this is going to start automatically fetch all of the geometry, and we can change the geometry that we want to select. And with the new update, you can actually go ahead and enter the viewer state and use A button. You can use an A and Control A, which basically all the controls are inside here. You can basically select which geometry we want to copy, we want to combine together. So let's say this straight one. I like this one. Now I want to create a new. I want to import another. I want to combine another geometry piece. So I could do it through multi-parameter. Just plus, and then I can press copy previous import data and select and start selecting new geometry. So I could do that, and then I can use the D and F button to select geometry from my current multi-parameters. So you can see that it's going to also be colored in light red color, which is color is selected inside here. I can also change the color that I want to color selected geometry, but actually I like this red one. So also the viewer state also has the gizmo that we can go ahead and move the geometry, and you can see the geometry is actually written inside here. The translate values, also rotation and scale values are all going to be written inside here. So let's say let's select something like these support beams. So there should be like a support beam inside here. This is the big ones, the small ones. Here we go. So this one. You just go ahead and move it in its place. Maybe something like here, and if you go in the right direction, you can go ahead and do something like this. And then for the railing height, so like something like a meter and 20 should be fine for the railing height. And then we can go ahead and duplicate the geometry. So the new for this update is going to be Control D, and Control D is going to automatically copy currently selected geometry into again, and we can go ahead and duplicate it. You can see if I press Control D again, new multi-parameter is going to duplicate currently selected geometry. So you can see it's a very simple way for you to go ahead and combine geometry together. Then I want to go ahead and copy it again, move it on the other side, like that. Copy it again, and you can use a control button for you to snap the distances in with these 10 centimeter integrals. Go ahead and do it again, and you can see we have basically almost set up our walkway. So another thing that you can do is create relative references for something like a height of these support beams, because these also always should be basically the same height. So what you can do is select the initial beam, which I think is this one, and you can see if you select, you can see the name of the geometry and also the index of the multi-parameter index. So I know that I started with this one, and that's the index 1, and I go through all of them. You can see that up until index 6, all of these should probably be on the same height as the rest of them. So go ahead and copy the first one, relative reference on the Y height, and just go ahead and copy all of these inside the rest of the multi-parameters Y, like that. You can see we can now basically change the height on all of them simultaneously. And then we also want probably some supports, some railings. So when I'm basically done with this one, I like to start it by not carrying over any of these translate. So I can do is basically just manually press plus and copy previous input data, and then just go to this geometry and start selecting some of these railings maybe. So you see I have a left and right railing. So let's go to the left one. Let's move it. Let's move it inside here. Let's go to the front like that, and just go ahead and align it like that. And then we can go ahead and duplicate it, move it here, and then press A to select the right railing. Go to the front like that, and we can basically almost set it up. So there's also support beams inside here. I have my support beams here, so I could probably also duplicate them here. So I want to again go to the new one, duplicate previous import data, go to that one and start selecting these. You can see there's a big one, that's a 2x2 beam, and it should basically be the exact size of the width of the platform. That's pretty good actually. And if you want, you can actually maybe even scale it a bit like that. And then you can just go ahead and press Ctrl D and move it here, Ctrl D and move it again. So you can basically recreate this platform from the scratch, and it was very interactive and it's pretty easy to do. So the thing that you have to be careful about doing is all of these relative references. If you start to delete some of these, so let's say you start to delete something like maybe the transform. So basically, if you delete some of these multi-parameters, this can break actually relative references to rest of the geometry, because basically this index is not valid anymore, and it starts to reference basically these parameters are starting to reference different geometry. So you have to be careful about deleting geometry once you have it set it up. So if let's say you do not want to use some of this geometry anymore, And if you do not want to recreate from scratch everything, you can basically go ahead and say disable some of this geometry with these toggles for each one of these. You can see there's a disable toggle for you to enable it for every one of these geometry pieces. So the straightforward modules are pretty simple. Now let's take a look at the corner ones. So the corner ones are pretty similar, but we have to approach it a little bit differently. So first of all, I basically want to do only the half of the module, because we can basically just go ahead and mirror the second part. So you can see that I'll make them together and I have my corner. But I have to do a little bit more of a setup to make it work for the Unreal Engine. So this involves having to modify a couple of attributes. So let's take a look at it. So first of all, the setup is basically the same, only with the 30-degree cut platform. I add more support at the middle of it, where the platform is going to intersect. Basically, where they're going to combine. And then I put down a mirror. I mirror at 30 degrees, and then I also go ahead and delete the geometry, these three parts, because these are actually necessary only one time. When we combine them together, they only need one of them, like that. But interesting part what we actually do is we actually update our up vector, and we basically make it point to the opposite direction. We basically just go ahead and multiply our up vector by -1. So this is done because of, if we are not actually doing it, let me show how it actually looks. And you can see that if we have not multiplied our attribute with -1, the geometry is not correctly rotated. So you can see that the platforms are not, you can imagine that basically what we want to do is rotate this geometry on its own axis on 180 degrees to make it match with the previous geometry. So this will be basically the same as me going to this platform, and let's select this one, duplicate it. I want to go ahead and, let's say, I want to move it to connect with it right here. But since I want to connect it, I need to rotate it 180 degrees, like that. Then you can see that we can start to connect and rotate it correctly, like that. So we could do it manually inside here, but since we can basically just mirror it, I just want to go ahead and put down mirror, and I have to multiply all of these pieces with -1 up vector, and I'm basically going to enable it also here. Let me save the geometry again. Let's take a look at it, and let's recook it. And you can see the geometry is correctly set up, and we do not have to manually align it anymore. So this is for the modules, for the angled modules. And what's great about this, we can easily get also the left and right module. We just go ahead and mirror it. We again multiply by -1 all the entire module, and then we also rename its name. We rename its ID. So in this case, I named my module right 30 degrees module name. In this case, basically in the triangle node, I find the word right and remove it, and with the word left, and now we have our left module. This is a primitive attribute, an ID. Then we just merge them all together. So let me go through quickly also to the 45-degree modules. It's basically the same thing, mirror. It's very simple. And once we have set this all up, we can easily modify our platforms however we want, and then we can just mirror them, and they all going to look correctly. So the stairs are very simple. We don't have to do any mirroring. It's just the modules set up, down, the big platform that I created just to showcase the end of the path, and also the steps, the kind of like a start step. And that's pretty much it. So the way that these modules are going to be instantiated along the pattern, so the name that I have set up is actually being used. So I have set up my name in this ID attribute, which is available for the geometry compositor node, but this doesn't have to mean that we have to use this name. The name actually is being assigned in this walkthrough pattern utility node. So there needs to be 3 attributes: angle, the name of the module, and the next piece position. So you can imagine that if we copy this module and we can connect any other module, it needs a place where the next module should be copied. And basically this is how we setting up where the next module will be copied, and with this next piece position attribute. And what's cool about this, that there's actually a gizmo inside. If you go ahead and enter the viewer state, there's going to be this kind of like a triangle where you can go ahead and set your next piece position manually in a viewport. And then I have set it up on all of my modules, and I just go ahead and set where the next piece should be instantiated. You can see all of these are set up where the next piece should be instantiated. Another important attribute that needs to be set up is the angle attribute. So the angle attribute describes basically the rotation of this corner, of all the corner modules, basically at where this module points to. And these angles are based on the transform node. So let's say we have transform and something like let's say we have a line, and I rotate it along to the positive z-axis and make it longer. And let's say I'm going to connect it and start to rotate it. So we need to make it so that it follows like here. So you can see that if I start to rotate it on the positive on the positive y-axis, so it's going to be actually on the left. So it is kind of counterintuitive. So the positive is going to be on the left angles, positive angles are going to be on the left, and the negatives are going to be on the right. So since this, let's say in this case, our module describes a 90-degree angle, we write angle is negative 90 degrees. And when we mirror it, that means this describes a 90-degree angle. So we write in a walkthrough pattern utility, it's a 90-degree angle. So this angle is being used internally by the walkthrough pattern tool to describe basically the next normal direction. And if I go ahead and allow editing of contents quickly in here, the logic is basically being set up here. And if you take a look at the normals of these points, normals, so you can see there's really it's not very involved at all, which basically we take the direction of the next module and we apply this rotation to the next normal. And this is going to describe the rotation of this is going to make sure that the next module is going to correctly align with the previous one. So you can go ahead and read through this logic, and it's really not all that complex. But by doing this, we are making sure that each module connects it through every time. So these are basically all the attributes that we need to set up. Our module name also, that is being used as an ID inside the walkthrough pattern nodes. So now that we have our modules, we just have connected our modules. So in this case, I have my source modules are from the input 1. And also there's going to be option which I have not yet tested out to save these modules on disk, and basically not to have all of these modules connected inside the heap file. We can probably create something like create a collection of modules and then read them from the disk instead of setting them up, basically setting them up in maybe different heap file and storing them as a module collection. So I haven't really tested that one out, so it's probably going to test out before I post this video. So, but let's take a look at how it works. So first of all, we have our setup, and setup of the attributes is we just go ahead and point to the attribute that is being set up to the walkthrough pattern utility. And by default, there's really no option for you to set up your custom names for the attributes, and the attribute names should be automatically set up for you. if you're using your walk through pattern utility, angle, module name, or next piece position attributes should be already set up if you're using utility node. And then the pattern is very simple. Let me go ahead and let's start by disabling everything except for one. So you can see it's a multi-parameter, and all of the modules are actually right here. And we can basically say how many modules you want to copy, and we have our pattern. So if I want my start position, start step, or if I want basically just a straight module, and I want to maybe like 10 of them, I can go ahead and instantiate them 10 of these. If I want my straight, and then let's say on the right 30, you can see it's going to copy this one time, and if I want to multiply it, you can see I can basically create however many times you want. And what's cool about this, that it's actually going to create a perfect shape for these corners. You can see it's going to connect it exactly. If you have like a angle, if you have like angle that you repeat many times. And then we can basically go ahead and use maybe like a stairs. We can use this and just repeat it however many times you want. And let me go ahead and you can see you can really go to many times as how crazy you want. So this is for the rigid type, but you can also go for the random ones. So the random one is actually going to select a random module from these patterns that you have selected inside here. You can see if I start to use random and I repeat it, maybe like I want 10 random modules and I start to use a seed, you can see you can basically create however many pathways you want. And then if you want to make sure that your modules always ends and starts with something with some module, what you can do is, like I had said it before, I'm going to start by my step start. You can see the first one is going to always be instantiated, and I want to also end with my platform 0, like that. So you can see my pattern is always going to end with module and start, and then in the middle it basically can be a random path that's going to create the path to this platform. This is a really cool way of making random paths that you can just take a look at them and create them like that. So this is the kind of like my main goal for this tutorial initially, because I wanted to showcase this cool tool that I made, and but obviously I didn't really found the specific geometry that I needed, so that's why I went to the creation of the geometry also. So that's made this tutorial a little bit more involved. And if you're not planning to explore the geometry outside Houdini, you're basically done. But if you want to get a point cloud and export it to the Unreal Engine, we need a little bit more of a setup. So since the geometry compositor node works on packed disk primitive points, so there's no really geometry. What I want to do is go ahead and extract the points from all of these references. So if you take a look at it, there's points and primitives are basically the same value, the same amount. So what I'm doing is I'm looping over each primitive, and I'm getting let's say I'm looping through this packed disk primitive. I extract point from it, and then I want to reference the Unreal attributes that we have set up inside that I showcase earlier in the tutorial. So you can use an unpack node. You can unpack and you basically get all the geometry, all the primitives unpacked, and get all the attributes. So inside here, we set up our Unreal input mesh name. We want to set this attribute as a Unreal instance attribute on our point. And this is where this simple code comes in handy. We basically check if Unreal input mesh name attribute is found on points. If it's not, that means that maybe it is on primitives. So if it's empty, then check on primitives this value, and then basically set it on our points as at Unreal instance points. And that's basically it. And then we can do it for all the points. And if you take a look at your points, there should be an Unreal instance attribute for all of these points. And the only thing that you need to do is save this geometry. And then, as I have showcased inside here, so this is going to actually be a different geometry. We can just recook. You can see this has been exported. Couple more things that I wanted to talk about is the setting up of the collisions inside Unreal Engine. So this involves us selecting this option where I showed there's to write collision and write vertex color option. So the idea is that we do not want to write collision or write vertex color for the geometry that we are going to use for the walkway compositing of walkway modules, because the geometry would be basically combined. So basically the geometry would be combined with the collision geometry, which is just a simple rectangular geometry, and it would not actually represent the view of the how it would look inside the Unreal Engine. And also the vertex color, we also do not want to write it inside the geometry that we're going to use to combine the geometry, because then it's going to look there's going to be some random colors on it, and it's not really also representative of geometry inside Unreal Engine. So what I have done is actually baked out the same geometry 2 times, and in this time I just went ahead and rendered it out inside its own specific folder called Unreal. And I want to import this geometry inside Unreal Engine with the collisions and vertex colors. And if we go ahead inside the Unreal Engine, let me show how it works. So if you can basically, I talk about importing geometry a lot more in my previous tutorial about importing geometry, my procedural building tutorial. So in here I'm going to just do it quickly and explain what I'm exactly doing in kind of like a big picture. So I have this asset called import geometry, the custom asset that you also can get if you support this tutorial. Then you can go ahead and say where you want to, what you want to import. Since you want to import multiple geometry, we set up our cook type to PDG, and then we have to point it from where we want to select our geometry files, and then just point to the Unreal folder that you have baked out your Unreal geometry here. And then you can basically leave everything else. So make sure you do not select recursive, because recursive would also search all the folders inside this directory, and we do not want to import something like temporary geometry. So make sure that's off. And remember that we want to also add the prefix for this geometry. So make sure that you add prefix static mesh. And since I know this is going to work, I'm going to auto bake it. So after the cooking, it's going to auto bake it to this directory as its own separate static meshes. I just go ahead and press cook output file, cook output, and I'm going to just wait, and you see that this content browser is going to fill up with this geometry. Then you can see that now it's after the cooking, it starts to bake it out, and this geometry is going to appear inside this directory that we set up inside Houdini. And you can see our geometry has been baked out with the static mesh prefix on all of them. You see this geometry has been very nicely baked out. And if you open up, you can see the 9line support has been automatically enabled, and the material also has been turned on. Now that I have imported back this point cloud, I want to showcase how we can set up our collision. So let's say I start the game and I try to walk through this walkway. You can see I'm just going through it. But since this time I have imported also collisions, I have to basically, these collisions has been imported as basically the player character is only responds with these simple collisions. So I want to basically use my collisions as a collision that I have set up on my static meshes, use them as a simple collisions, even though they have been imported as a complex collision. So let me show how it works. So the simple collisions would not really work for something like these stairs, because there's lots of intricacies to the stairs, and the simple collision would be like wrapping it around like a shrink wrap, like a box and all of that. So I want to make sure that I use a complex collision. And the complex collision that we set up inside Houdini can be seen from this complex collision option. You can see even though it's called complex collision, there's really nothing too complex about this collision. There's not like thousands of polygons. It's just a box around each piece of the geometry, and we want to use this geometry for our collision with the player. So all you have to do is to make sure that you apply all of it to all the static meshes. Just go ahead and select it, and then use the matrix, edit matrix, and go to the search for collision. I think you also have to select all of these. There's also collision complexity, and just set use complex collision as simple. Just set this up. It's going to think about it. It's going to be set it up. Just save it, and basically we have set up our collision now. And if you go ahead and go to the collisions, player collision, you can see some of the geometry is starting to show the collision. And if you go ahead and play the game, we should now be able to walk through these pathways. You can see we have now collision, and we're not going through this geometry. So you can see we have our collisions. Now what's cool about this, since our collisions are pretty straightforward and not too general, you can see that even something like these steps, you can see our characters actually stepping in between two steps. So that's why our collisions are pretty actually nicely set up. So that's it for the collisions. It's actually very simply set up inside Houdini and then used inside Unreal Engine. And one more thing that I want to use, I wanted to showcase how I have used the Vertex colors, is this kind of like edge damage look for the wood material. So it is actually very simply set up, and I just tried it out just as a demonstration and how it can be enhanced. Basically what I have here is my material, and I have basically just created another material based on the Megascan surface shader, master shader. And if you take a look at it, it's basically the same shader that is being used by the Megascan's default surface shader, and the only thing that I have here, I have taken our vertex color for the geometry, and I know that in the green channel I wrote my curvature vertex colors, and then I just apply a little bit of a contrast on it, and then I add one to it, and then I multiplied our base color texture with it, and that's basically it, and we put it in the base color. And this gives this kind of and there's also option for me there's a convexity strength to control. You can see we can control the look of it. And let's say I go ahead and disable it. Let's say I have disabled this inside the shader. You can see that it looks pretty bland. It still looks okay, but it does really give a little bit of a better highlighting for the material using these vertex colors for these materials. So I think it's definitely worth using these. And this is everything that I wanted to show in this video. I hope you learned something, and see you next time.